Hi, my topic is about the physics of music and noise. The distinction between music and noise is mathematical form. Music is ordered sound. Music and noise are both mixtures of sound waves of different frequencies. Noise is a disordered sound. The component frequencies of music are discrete, which is separable, and rational. Their ratios form simple fractions with discernible dominant frequency. The component frequency of noise are continuous. Every frequency will be present over some range and random with no discernible dominant frequency. Sound is a longitudinal wave, which means the particles of the medium vibrate parallel to the direction of a propagation of the wave. A sound wave coming out of a musical instrument, loudspeaker, or someone's mouth pushes the air forward and backward as the sound propagates outward. The simplest sound to analyze mathematically is the pure tone, one where the pressure variation is described by a single frequency. A pure tone would look like a sine curve when graphed style, which is described using the formula y equal to a sine 2 pi ft, in which y is the instantaneous value of the microphone voltage, a is the amplitude or maximum value of the waveform, 2 pi is the constant needed to get the units or to work out, f is the frequency, and t is the time, of course. Music in its simplest form is monotonic, that is composed only of pure tone. Monotonic music is dull and lifeless like 1990s ringtone, like a 1970s digital watch alarm. While real music, however, is polytonic. The act of combining pure tones together to produce a complex waveform is called additive synthesis. Non electronic instruments do this naturally. Electronic instruments, if they want to be taken seriously, are designed with additive synthesis in mind. The analog synthesizer is a good example of this. Generate a sinusoidal electric signal of with an oscillator of fairly simple electric circuit composed of a capacitor C and an inductor L, also known as an LC circuit. The human voice and musical instruments produce sounds by vibration. What vibrates determines the type of the instruments, like bass voice singing, trumpet, violin, or some of the oscillation traces for various instruments. Example. Classification of the musical instruments are shown in this figure, like category and vibrating part examples are given in this picture. The next topic is about noise. Noise. Music is sound with a discrete structure. Noise is a sound with a continuous structure. Music is composed of sounds with a fundamental frequency and overtones. Noise is composed of sounds with frequencies that range continuously in value, from low as you can hear to as high as you can hear, not necessarily at equal intensity, however. Noise is what you hear when you tune an analog radio or television to an empty frequency. It's the overall sound of rain falling on leaves, soda bubbling in a gas, air escaping from a tire, or crowd applauding. There are some colors that define the noise, like white noise, pink noise, and crowd cheer. What is a white noise? White noise is a sound with a flat power spectrum, that is, it transmits power equally at all frequencies. It is a mathematical idea with the representation something like this: P of f equal to constant, so that P equal to f minimum to f maximum, P of f df equal to P delta f. P of f, the value of the power spectral density. F is the frequency of the human hearing. P is the total power output of the source or some quantity proportional to the practice. What is a pink noise? Pink noise is a sound with a power spectral density that is inversely proportional to the frequency over the range of audible frequencies. Because of this, it is also known as 1 over f noise. We can write this as a proportionally statement p of f inversely proportional to 1 by f. As an equation with a constant of proportionally k, p of f k divided by f. At the end, a sampling of different scales are shown in this picture.